We're now going to look at non-right angle trigonometry example 3, and this example will involve angles of elevation, which we covered earlier in the course. So it says a person is at a point C on the ground and they see a vertical tower AB of height 12 meters where B is on the ground. So let's stop at the end of the first sentence and start to draw the diagram that reflects that information. So we have ground. We'll represent that with a horizontal line, and then there is a tower. So we're right to assume the tower is built at right angles to the ground, and the tower is AB where B is on the ground, so we'll mark that point B, and then the top of the tower A. We're told that the tower is 12 meters, and we're also told that a person is somewhere in the ground at a point C. So we'll mark a point C somewhere there. So that reflects the information given in the first sentence. Okay, let's deal with the second sentence. It says the angle of elevation of A from C is 35 degrees. Now remember, how do we draw an angle of elevation of A from C? So there's the key phrase there. We want to show the angle of elevation of A from C. So you go to the letter that comes after the word from. So we go to C. We then join C to A, and that is called our line of vision. It's an imaginary line in mid-air. And the angle of elevation of A from C means you go to point C and it's the angle measured up from the horizontal at point C to the line of vision. So that angle in there is 35 degrees. That's the angle of elevation of point A from point C. So the angle is measured at C or from C to the line of vision connecting A and C. So let's do the next sentence. It says the angle of elevation of A from D, which is another point in the ground, is 45 degrees. Now, as you move closer to the tower, the line of vision is going to make a steeper angle with the horizontal. In other words, the angle of elevation is going to be steeper. So point D must be somewhere closer to the tower. So we're going to draw or plot another point D. We're going to draw another line of vision from D to the top of the tower. And now we're told that the angle of elevation of A from D is 45 degrees. So that's going to be this little angle in here. Remember, angles of elevation are always measured up from the horizontal. Now, let's just check to make sure we've got all the information given in the question. Yep, we've got absolutely everything given in the question, and then it's asking us to calculate the length CD. So we're looking for this distance here. Now, just like the previous examples which involve bearings, if there's any angles you can work out just by using simple maths, then go ahead and work them out. For example, we could work out this angle in here, because these two angles are angles on a straight line, so we can take 45 away from 180, and that's going to leave us with 135. And likewise, we can also work out this angle up here, because these three angles are in a triangle, so they add up to 180. So 135 plus 35 is going to give us 170, and then take 170 from 180, the angle up here is just going to be 10 degrees. Again, you could go further, you could actually work out an angle in here as well. This is a right angle triangle. Again, the angles add up to 180, so we've got 90 plus 45 is going to give us 135, and then subtract 135 from 180 and that's going to give us an angle up here of 45. So it's a good idea to work out those angles first. It makes life a bit easier. Now, we want to work out CD. Now, CD is part of this non-right angle triangle. Now, you're thinking, let's use non-right angle trig. But the problem is, you don't know enough information about the non-right angle triangle. The only thing you know are the angles. If you cast your mind back to the sine rule or the cosine rule, to use the sine rule, you need to know an angle and its corresponding side and any other measurement. But the problem is we don't know any sides, so you can't use the sine rule. You use the cosine rule when you know two sides and the angle between them, but we don't know any sides. And you also use the cosine rule when you know all three sides. Well, we don't know any sides. So that's why at the minute we can't use the sine rule or the cosine rule. We would need to work out one of the three sides before we get CD. So that's where your attention then flips to the right angle triangle. Can we work with the right angle triangle and find the common side? In other words, the side that is part of the right angle triangle and the non-right angle triangle. And the answer is yes, because I'll remind you, to use right angle trig, you need to know either a side and a given angle or two sides. Now, we know a side and a given angle, so we can use right angle trig. So we're going to get the common side first. We're going to get DA first. So we need the common side DA first. So we're going to get that using the right angle triangle. So let's copy out the diagram, and every time we work with a triangle and we're using trig, make sure we copy the diagram out. So copy out our right angle triangle and label the corners. Now, again, I could put 45 up here, but it doesn't matter, because to use right angle trig, you need to know either an angle and a side, a given angle and a side or two sides. So we know enough already to use right angle trig. Now we want to get DA. This we're going to use as our given angle. So we're going to label the two sides involved in the question with respect to this given angle. So this side is opposite the given angle, that's the side we're given, and the side that we want is opposite the right angle, so it's the hypotenuse. So the trig form that involves opposite and hypotenuse is sine. So we're going to write out not the sine rule, the sine formula, which is for right angle trig. So sine theta equals opposite over hypotenuse. And then we sub in the information. So sine 45 is equal to 12 over the hypotenuse. So we're going to put sine 45 over 1. And we're going to cross multiply. So we're going to get sine 45 multiplied by the hypotenuse is equal to 12. We're then going to divide both sides by the coefficient of the hypotenuse. So we're going to get the hypotenuse is equal to 12 over sine 45 So what we're going to do then is cancel the sine 45s on the left hand side. So we're just left with a hypotenuse. So the hypotenuse is DA. So what I'm actually going to do here is I'm going to actually work this out. I know we would normally keep it exact, but we're going to end up having to use this very shortly with our non-right angle trig formula. So we'll work this one out. So the hypotenuse is equal to, so we'll go to our calculator. Again, we'll hit our fraction button. So we've got 12 over sine of 45. And then hit equals, and again it's going to give us 12 root 2. Actually, that's a good way to leave it. So we'll leave it as 12 root 2. We'll leave it exact with a root in it. So that's going to be 12 root 2. And the units there are going to be centimetres. So at the minute we've worked out dA. So dA is 12 root 2 centimetres. So let's go back to the question. Remember, the question's asking us to work out CD. The reason we've worked out dA is because we need to know one of the three sides of the non-right angle triangle in order to use non-right angle trig. So now we can get CD using the non-right angle triangle. So we're now going to get CD. So we'll copy out the non-right angle triangle. Label the corners. Put all the information on. And then remember, we worked out AD. AD was 12 root 2. Okay, and that's all the information. Now we're trying to work out the length from C to D. Now this is clearly a non-right angle triangle, so we're going to label all the sides with small letters. So this side is opposite angle D, so we're going to call it small d. This side is opposite angle A, so we'll call that small a. And finally, this side is opposite angle C, so we'll call it small c. Now, are we going to use the sine rule or the cosine rule to get CD? Well, let's look at what we know. We know an angle and its corresponding side and other measurements, so we can use the sine rule. We can't use the cosine rule because to use the cosine rule you need to know two sides and the angle between them. We only know one side, and the other time you use the cosine rule is when you know all three sides, and we don't know all three either. So that's why we use the sine rule. So we're going to use the sine rule. Okay, note the difference, sine rule, not sine formula. Sine formula is for right angle triangles. We're using the sine rule for non-right angle triangles. So we're going to write the sine rule down in terms of the letters A, C and D. So we're going to get A over sine A equals C over sine C, and that's equal to D over sine D. And again, we tick off everything that we know. We know all of the angles, so we can tick off sine A, sine C, sine D. We know small c, so we can tick that off, and we want to find small a. So we're going to use the first two fractions of the sine rule. So let's sub everything in. So we're going to get a over sine of 10 degrees, and that's equal to 12 root 2 over the sine of 35 degrees. So we've got one fraction on each side, so we're going to cross multiply. So we're going to have a sine 35, and that's equal to 12 root 2 sine 10 degrees. Now a sine 35 is the same as sine of 35 multiplied by a, so the coefficient of a is sine 35, so we're going to divide both sides by sine 35. So we're going to cancel the sine 35s, one on the top, one on the bottom, so we're just going to be left with A. And then we're now going to go to our calculator and we're going to type in the fraction on the right hand side. Again, make sure we're in degree mode all the time for these. Okay, so fraction button, we've got 12 root 2, and then scroll across to the right and type in sine of 10, close brackets after the 0, and then on the bottom line we're typing in sine of 35, close brackets after the 5, and then scroll the little flashing line halfway between numerator and denominator, hit equals, and that's going to give us 5.1377. And then finally we're going to round our answer to 3 significant figures. So you go to the third significant figure, then you go to the digit after. Digit after is 5 or more, so you round the third one up by 1. So our final answer is CD is equal to 5.14, and it should be meters, and that is to 3 SF. So apologies, the length should all be in meters. DA is obviously in meters as well. So, great question. It's a great question because it combines your knowledge from M4, where you were working with right angle triangles and finding sides or finding angles, with now what we're doing in M8. We're using non-right angle triangles and we're finding sides and angles. But the key point is, always try to work out the common side, because once you know the common side, that unlocks the rest of the question. That allows you then to work with the other triangle, and vice versa. You might have to work with the non-right angle triangle first to get the common side, and then that will allow you to work out an unknown side in the right angle triangle. So it works in both ways.